Hey guys, welcome back to another LeetCode tutorial. In this video, we are looking at problem number 104, that is to calculate maximum depth of a binary tree. According to LeetCode, it is of easy difficulty and it has been asked by companies like Apple, Google, and Amazon before, and it has a good like and dislike ratio, so it is quite popular. Now, let's try and understand the problem statement. The first and foremost thing is we are given a root of a binary tree and then we are supposed to return its maximum depth. And to understand the definition of maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So if you look at this tree visually in example 1, you can start from root with a value 3 and then go one level down, which is 2. So the maximum number of nodes here in this path is 2. So the depth is 2. Likewise, if you go onto the right subtree, you go to 20 and then you take a left. Here it is 15 and then it's the leaf node. So the number of nodes it took is 1, 2, and 3. So the maximum depth is 3. It is similar to the other path, which is 3, 20, and 7. It's also the max depth is 3. So the output is 3. How are you going to solve this programmatically? If you look at the approach, we are going to have this tree, and let me add it here. So imagine having a tree with only one node like this. So what is the maximum depth of this? It's just single node. So we are going to have our result as 1. But what we are going to search during this check is we are always going to have 1 for sure. If you find a node, the depth of that node is 1. And then you're also going to check its left subtree, and then you're also going to check the right subtree, and then you're going to add it with this one, but you're only going to add the math.max version of it because you need to first calculate the left subtree's depth, right subtree's depth, and then add it to your current node's depth. So that is the formula, right? And you are doing it for a single node here if the tree has only single node. But if you have a tree with multiple nodes with different levels, then you're going to calculate it the same formula here at each and every level. So for example, if I have 2 and then I have 5, uh, and if I add a tree like this with 1, so what is the maximum depth here? In this case, you're going to calculate 1 plus math.max of left subtree and right subtree. So you're going to first start off with the left subtree here. In this case, you navigate from this node to 3 to 2, right? When you're navigating from 3 to 2, we are going to uh, check if this node has left subtree and right subtree. So you're going to go to another level, um, which is 1, and then you're going to try to go to another level, which is one's node dot left or root dot left, and then you'll hit null. When you hit null, when you reach null, you have reached the leaf node. Okay, that means you return 0 because there's no node there. So the depth for that particular node, null node, is 0. Okay, and then you check for the right of the this node, leaf node, and then you won't find any um, uh, depth there because it's a null node. Then you immediately return 1. Sorry, you return 0 from there. So you are at this level where the depth is 1 because you have your left. So let me write it down here. So you are at node 1, right? When you're at node 1, left depth, I'm just going to call left depth is 0, right depth is also 0, and then depth equal to 1 plus math.max of 0 comma 0, that is 1. Now you check, um, you go back to node uh, node 2 here, and then check for the right. So you will be at node 6. At this case, left depth is 0, right depth is also 0. The depth will be 1 plus math.max of 0 comma 0, that is also 1. So at this level, we have calculated the depth at this level. So it is 1 1, and for 2, when you are going to return back to 2. When you are at node 2, your left depth is 1, your right depth is also 1. So the depth of the node 2 will be 1 plus math.max of 1 comma 1, which is 1. So the total will be 1 plus 1, that is 2. At this level, you are at the depth of 2. Now you are returning back to 3. But as soon as you reach 3, you're going to check, you're going to do uh, root dot right. In that case, you are going to go to node 5. So LD, and then you are going to do a check on the left. That will be null. That returns 0. So left depth of this will be 0. And then you are going to check the right of node 5. The right is also null. So you are going to get back 0. So the depth of node 5 will be 1 plus math.max of 0 comma 0, that is 1. Okay. Now you are at node 3. Okay. Now node 3, the left depth of node 3 and the right depth of node 3. Here we have got the left depth of node 3 at this level. The direct child of 3 is 2 and 5. So when you look at node 2's depth, that is going to be the left depth of node 3, right? So that is 2, and the right depth is the depth of node 5, that is 1. Now the formula to calculate the max depth of this is 1 plus math.max of 2 comma 1, that is 1 plus 2, that is 3. So the maximum depth of this tree given root as node 3 is going to be 3. So that is how you calculate the output as 3. I hope breaking it down uh, at each level of the recursion made more sense. Um, yeah, unfortunately, like I cannot uh, draw it here. So this is a visual reference that I could come up with. So let me know if you have any questions about this. I'm going to jump into the solution now. So first of all, imagine a root as null. So we don't have any root. In that case, you return 0. So this is also true in the case where we reach the leaf nodes, right? So when we reach the leaf node 1, the left depth and right depth is 0. So you return 0. Otherwise, if you have a left subtree, then you're going to calculate left depth is equal to, you're going to recursively call this function and then say root dot left, and then you're going to do right depth is maximum depth of root dot right, and then you just finally return 1 plus math dot max of left depth comma right depth. Okay, so this 3 steps are true for every node in the tree. Okay, so you start off with 3. So since we have a root, so we won't go into this if condition. So we are going to call the max depth again with this nodes left, what that is 2. So it's going to call the same function with 2 recursively. Now for 2, since 2 is not null, so you are going to call the same function max.depth again with its root.left, that is 1. Now again, it won't go into null root because we have a root at that point, which is 1. Now again, we are going to call max.depth with once left. Okay, once left is null. So it's going to get into this if condition this time. Okay, now we will be returning 0 to this. The left depth for 1 is 0. Then, um, then the control goes back to the previous call on the stack where it will continue on the right depth. So we are going to calculate right depth. So once right is also 0 because it has null. It's a leaf node. Then we are going to calculate the depth of that particular node. That is 1 plus max of left depth and right depth. That's how you get the max depth as 1 for just this node. Okay. And the control goes back to 2 and it's going to go here because we have already come out of this max depth on the root dot left. So it's, when you come on to the line number 17, in this case, you will be calculating the node equal to 6. Again, it's going to be similar. Left depth and right depth will be 0 for this. So uh, you return 0 0 for left depth and right depth, and the depth will be returned as 1. So now you can calculate the max depth of 2 because you have covered its left subtree and right subtree. So you now have an idea of what the max depth of at node 2 is, right? So you just calculate it with 1 plus math.max of 1 comma 1, that is 2. And then you return from here to the root node, which is 3. At this point, you have already calculated, you already went through 2, 1, and 6, the entire left subtree, and the maximum depth that you could go was 2. Now you want to make sure that you are also covering the right subtree of this from this node to make sure if it is greater than the left subtree's depth, that is 2. So you go back to 5 and then you check left and right, that is left depth and right depth is 0. So the depth is only 1. You return back. Now 3 has a left depth as 2 and right depth as 1. So the maximum is 2. So you're just going to put the same formula, that is you're considering this level plus the maximum depth of its left subtree and on the right subtree, the maximum is 2. So you calculate 1 plus 2, that is 3. So that is how you solve the problem of maximum depth. I hope this is clear to you guys after going through each of these recursive steps on the tree. Now, if you have any questions at this point, please try to ask them. Please feel free to ask them in the comment section. I'm going to be responding to each and every comment. And you should also try writing this program to understand get used to the concept of recursion if you're new to solving tree problems, especially. And yeah, let's go ahead and run the solution. As you can see, it has passed for these two cases. I'll go ahead and submit the solution, and this has been accepted. That is how you calculate the maximum depth of a binary tree. I hope you have learned something out of this video and it was not very confusing to you guys. So if you have learned something, please give it a like and share it with whoever is preparing for interview questions or whoever is preparing for interviews. And please consider subscribing to my channel as I'll be posting more videos and it's going to help me grow my channel as well. And I hope this video added some value. So yeah, And then I'm going to be posting more lead code problems in the further tutorials. Thank you so much for watching, and I'll see you in the next one.